Okay, listen up, listen up. All right, so again, the midterm is next week. There are no regular office hours, okay? So I normally have office hours from 5 to 6. I will not have those office hours next week. Instead, I will have a review session from 6:30 to 7:30, 7:40 next week, okay? So same, just come here, come prepared with your questions and whatnot. You can turn in your homework, pick up your quizzes at that time, see what happened. Any questions you have, that's the time to ask. The exam itself will go from 8 to 9:30, okay? The exam is multiple choice and short answer. Okay, so the quizzes so far have all been short answer. The midterm will have a multiple choice part and a short answer part. Okay, I will provide you with Scantron forms. Make sure you bring a pencil, eraser, a calculator that works. Okay.
And what's Scantron?
I will give you Scantrons. Okay. You are allowed a sheet of notes, okay, writing only on the front side, okay, so a full letter size piece of paper, writing on one side, that's it. The note can be typed, okay, that note sheet can be typed, but you must make it yourself, okay. If it looks like you photocopied someone else's note sheet, I will not let you use it, okay, so you must make the note sheet yourself. There is a page on the website that says about the midterm exam. It lists off some topics that you should need to know, okay? That covers probably like 90–95% of the midterm, okay? There might be one or two questions that's not listed on there, all right? Please don't come and say it's not fair, all right? I provide that as something to help you, okay? I could just say you've got to know everything and not give you this list, okay? But I'm giving you a list that covers about 90–95% of the test, right? There might be a question or two that's not on that list. Don't be too angry, okay? Are there any other questions about the midterm? Yes?
How many questions?
The exam is written to be 90 minutes. There are 25 multiple choice and 4 short answer questions. If you get all the questions right, you'll get 110% on the exam, which in my opinion is generous. Yes?
When did you say was the review again?
6:30 to around 7:40-ish.
But you were here earlier, you said? No?
I will not have regular office hours from 5 to 6.
Okay, so 6:30 to 7:30 is review.
Yes, 7:30, 7:40. Okay, in this classroom.
Regular class time.
Regular class time. So just come regular class time. The first part is where you can ask questions, things like that. Make last-minute changes to your note sheet. That's fine. All right. Of course, all of your studying should happen prior to that time, and you can ask just some last-minute questions. Anything else? Okay. I'm going to pass out some papers here. All right. These papers are for you to keep, and it is your responsibility to keep them in a safe place. All right. They are reference tables. Today we're going to learn how to use these reference tables. Okay, they're just photocopies of pages from the back of the book. I'm sorry? Yeah, from the appendix. Okay, we're going to learn how to use these. These are your responsibility to keep in a safe place. Because in future quizzes, you will need to use the reference tables. Okay, and this will be the one time I pass them out. Okay, if you come on future quizzes, so quiz 3 or quiz 4, you say, I forgot my reference tables, I'm going to say, I'm sorry. Okay? For the midterm exam, I will provide copies of the reference tables. You will need them, but I will provide the reference tables on the midterm exam and the final exam. But for quizzes, you've got to keep these. Okay, you got to bring them and stuff, just like bring your calculator. Okay. Again, for the, next week it's the midterm. Don't forget your calculators. You guys are adults. I don't know what to say when students tell me they forget their calculators. Oh, so there's two pages. Okay, there's 2 pages of tables. I'm sorry. You might need to call them back here. Okay. So, is that enough for everybody? Here, you'll need both of these, and you'll need both of these, and you'll need both of these. Okay. All right. Well, all right. I'm just gonna hand this stack out. Okay, hand this stack. Go around. Take 2 pages. Take 2 pages, and that's what you need. Okay. So basically, you need table 2 and table 3. There's 2 pages. Table 2 and table 3. Just take the stack, pass it around, and it should be good. Extra. Okay, great. All right. Before I get into chapter 6, are there questions for anything? Midterm, chapter 5, chapter 4.
Can I take 2 extra for my son?
Okay, I'll give you extras. Okay, if you need extras, get them at the end. Okay.
Yeah.
Questions? All right, everyone's good? No? All right, well, we shall get started then. All right. So chapter 5 was about probability. Chapter 6 is more probability, but we are going to deal with probability models. Particular, we will learn about the normal model and binomial model. Normal model and binomial model, they are models. They show us kind of what things should go like in theory. Maybe not exactly, all right? But it's like an idealized version of what could happen in reality. Okay, so what happens in reality will never follow a model perfectly. But this is an idealized version that's useful, that gives us an idea. All right, so let's, and let me just talk a little bit about something called a probability distribution. Okay, so these are, the normal model and binomial model are both examples of a probability distribution, okay? And what a probability distribution or a probability distribution function does is it takes the outcome of a random event and it basically gives it a number, okay, and it tells us the probability of that particular outcome. Okay. So let's try this. So maybe we have a coin flip. Okay? So coin flip, if we have a regular coin, so your quiz you had a special coin that didn't land 50% heads, but here we have a regular coin. So let's just assume a regular coin will land heads with probability 0.5. This in of itself is not a probability distribution. We have to take the outcomes of a coin flip. What are the outcomes of a coin flip? Heads or tails, and we have to give them a number. Okay, so coin flip, we have heads or tails. Any foreign language speakers what do they call the two faces of a coin? Is it always heads and tails, or is it, do they have, what would be the English literal translation for front and back? Is it front and back?
Depends on what coin you're tossing.
Oh, it depends on the coin.
Like how it looks like.
No.
Like some coins have, like a crown or.
So they'll say crown one side and the other side. I don't know. Oh, interesting. Yeah, I mean, being American English speaking, I'm only familiar with heads and tails, but
I guess it's like the king's head. Well, in Sweden it's like the king's head and then versus crown.
okay. So what would you so
So heads and crown.
heads and crown? Interesting.
I guess.
Yeah.
We would have heads and writings.
Heads and writing. Interesting. Okay. And the technical terms are actually for obverse and reverse. Obverse and reverse. If anyone cares, but we generally colloquially say heads and tails. Okay, so these are not. This is not a probability distribution. We have to assign a number to these. Okay, so we can say heads is equal to 0 and tails is equal to 1. It doesn't matter, okay? We could also say heads is equal to 1 and tails is equal to 0, however you want. But if we say heads is 0 and tails is 1, suddenly we now have a probability distribution, okay? And I could have something called a probability table. And the outcome and we have the probability. And over here the outcome is we have 0 and we have 1. And the probability of this outcome is 0.5. And the probability of this outcome is 0.5. So all I've done is taken the outcomes of a coin flip, turned them into numbers, 0 or 1, and then wrote out the probabilities of those outcomes, 0.5 and 0.5. Okay, is that okay?
0 and 1 is the categorical representation.
It's the numeric representation of a categorical outcome. Okay. All right. Is that okay?
Yeah.
All right. So what if we had a strange coin? So this is, I don't know, maybe it's weighted or bent or something. All right. So let's say it lands heads with probability equal to 0.29. Okay. And again, let's say we have heads equals 0, tails equal 1. My probability table, I have the outcome and the probability. What do I write here?
0.29.
And what would I write here?
0.6,
The difference.
7, 1.
Is that?
Mhm.
Is that okay? Yes, question.
This is silly, but like, why do you never write 0.5?
Why do I never write
Would that be
0.5?
wrong? Or-
Oh no, that's
No.
fine.
Like, it's okay to write either way, right?
Yeah, those are.
You
those
just
are-
prefer. Is it an
I
English thing?
I don't know. I guess
It's a placeholder.
it's I'm accustomed to writing it this way, but you don't have to.
Okay.
I
Okay.
guess. Would my style be wrong in
No, I'm
in
just
a foreign
no,
country? I
I'm
don't know.
just,
I don't know.
like,
Yeah.
I just
Yeah,
want to make
you know-
sure that I don't get like minus.
No,
points
no,
or something.
absolutely not. You know, I know in other countries, especially European ones, use comma
Yeah.
to
Exactly.
separate whole numbers from
Mhm.
fractions of numbers. I know that's you know, and then your date is also written day, month, year, rather than month, day, year. So everything is different, right?
Yeah.
We live in a diverse world. Okay, so these are simple examples, and so let's try this out, okay? So imagine you've got this, you've got a wheel, okay? And let's see. There's 12 divisions on the wheel. Okay, and then there's I don't know, a little thing, and you spin it. All right, and then it goes round and round and round and round. Okay, if you is this? Can you guys imagine this? It's like okay, and then it goes. Okay, so if it goes here, you win. We'll say you win. I don't know. Yeah, $5. Okay. And then if it goes here, there, or there, these are $1 each. And then the rest is 0. Okay, everyone's good? All right. So take a moment and make a probability table of how much you win and the outcome and the probability.
Does it matter how many keys?
Okay, yeah, there's 12 equal, I don't know, slices. Alright, are we done?
Yeah.
No?
We're still drawing.
Still drawing your picture. Alright, what are the different outcomes from least to greatest? The first outcome that's possible is
5.
0.
0.
0, going from least to greatest. What's the next outcome that I can have? 1 or
5.
5. What's the probability of getting 0?
8 out of 12.
8 out of 12, good. And what's the probability of getting 1?
3 out of 12.
3 out of 12, and 1 out of 12.
Yeah.
Very good. Okay. Is that alright?
Yeah.
Okay. Sometimes we want to represent these graphically. Okay, or so if you don't like fractions, you can also go into decimals, which is how when we do binomial stuff, it's represented with decimals, okay? So this is going to be 0.667, this is 0.25, and this is 0.1667. No, 0.083. I'm sorry. Okay, and then sometimes we could represent these with a graph. Going from 0 to 1 would be 0.5. Okay, so if this, if our first number is 0, that happens with probability 0.667. Okay, that's right around there. I don't know, maybe a little bit lower. Right there. And then 1 happens with probability 0.25, so that's right there. And then 5, so this is 1, 2, 3, 4, and 5. This happens with probability 0.0833, so that's just that little line right there. So I'm just drawing lines to represent how tall these numbers are. And this is called a probability density function. Is that okay? So we have probability density functions, and they can be represented with lines like this. This is because we can only take on certain outcomes. This is known as a discrete, the discrete case.
Why did you say?
Huh?
Why did you say?
What did I? It's for a discrete. Discrete. This is that's the word there. Discrete case, and we also have a continuous case. Okay. So discrete case means only certain values possible. Okay, so like only you either win $0, you win $1, or you win $5. Okay, if you play this game, there's no way for you to win $3, or there's no way for you to win 25 cents. Okay, the outcomes are you win 0, you win 1, or you win 5. That's it. How much should it cost to play the game? This is a good question. How much would you be willing to play the game? Pay to be willing to play the game?
5 cents.
25 cents?
5.
$2? Do you pay $2 to play the game?
Because we don't want to go to one.
12 cents.
say 25 and then 12, 5, 5, 12. The answer is like,
Like 5 cents.
I don't know,
What is
like
the
67 cents or something, 66 cents.
What's the question?
How much would you be willing to pay to play this game? That's
And
it.
how did you figure it out? You guys did 1/4 of 25?
No, I'm just multiplying those numbers together and adding them up.
Oh, okay.
It doesn't matter. Okay. Yeah, so if somebody says it only costs 50 cents to play, you should definitely play it. You should definitely play it. All right. So that's the discrete case. Okay, discrete spelled D-I-S-C-R-E-T-E. Okay, which is different from please use your discretion and be discreet about this sensitive matter, which means something else. Okay. So we have the discrete case. We also have the continuous case. Okay. So the continuous case means your value can take on all of these decimal values in between, depending on how accurate your tools are. Okay? So you can take on decimal and, you know, with any value within a certain range is possible. Okay? So it could be how long do we have to wait for someone's phone to ring? Okay. How long do we have to wait for someone's phone to ring? Whether it's silenced or not, just how long do we have to wait for someone to receive a phone call? Okay. That could be anywhere from 0 minutes to, 100 minutes or however long, okay? It's very possible that we wait exactly 5 minutes. It's possible that we wait 5.06 minutes or 5.0673 minutes, okay? If we had a very accurate way to measure time, we can take on practically any value, right? Okay, so. So practically any value is possible. Could wait 5.00 minutes. Could wait 5.1436 minutes. That's what we're saying. Okay? So that would be the continuous case where we can take on all of these values. And because we can take on all these values, we don't represent the function with straight lines at particular values. We draw a curve. And maybe the curve looks something like this. It says, where the height of the curve tells us the relative probability. Okay? Height of the curve tells us the probability, or what we call the density. And so to get actual probabilities, we must figure out the area. And this is the probability that we have to wait this particular length. We have to wait within this range of time. Because if I ask, what's the probability that we will wait exactly 5 minutes for the next phone call? What's the probability of that? Exactly 5.000 minutes. The probability of getting exactly 5 minutes is 0. Okay? But I could say, what's the probability that we have to wait between exactly 5 minutes, and exactly 5.5 minutes. Then we have a not a zero probability, okay? It might be a small probability, but it's not zero.
So you're saying the exact rate cannot never happen?
Yeah, we will never get an exact number, assuming we can measure things out to incredibly
Okay.
infinite accuracy.
Got
Okay?
it. Yeah, yeah.
Okay?
Yeah.
Is that okay?
Mhm.
It's just like, what's the probability that someone in this classroom weighs exactly 130 pounds? Okay? Probably somebody weighs, if you asked how much do you weigh, they might write, I weigh 130 pounds. There's probably someone who would say, I weigh 130 pounds. But if we put that person on a scale, okay, is it going to be exactly 130 pounds? Probably not. If this scale is incredibly accurate, it might be 129.9967 pounds, okay, or something like that. But if we had an incredibly accurate scale, it probably will not say exactly 130 pounds, okay? So the probability that someone in this classroom weighs exactly a particular weight is 0. But if we say, what's the probability that someone weighs between, 129 and 131 pounds, there's, I'm sure somebody weighs something around there, okay? Is that okay? Okay? So the probability we always ask, what's the probability of getting within a range of numbers? Okay? Ask. Oh, ask. Never ask. Always ask. Okay, so with that, now I can introduce the normal probability distribution. Does everyone have a copy of the reference tables? Okay, both normal and binomial? Yes, because we're going to use those now. Alright, and if something happens, like you lose these tables, okay, then it's your responsibility to make your own reference tables. All you have to do is you go to a photocopy place and you just photocopy pages, these pages from the back of your book, okay? Because that's all I've done for you, all right? But you guys are grown-ups. I've given you one copy, okay? If you lose it, it's your responsibility to replace them, okay? All right, and if for those of you who chose not to come to class today, all right, then you have to get the tables yourself, okay? Normal model or the normal distribution. Alright, these are two names for the same thing. So things in real life sometimes follow the normal model, or the normal model, approximate things from real life pretty well, such as the heights of people. Okay, so like especially if we talk about one gender or one sex, the heights of people often follow the normal distribution. Heights of people, IQ scores, intelligence, generally follows the normal model. Even SAT scores to some degree, a lot of different things measure length of bones, whether it's in your arm or your leg. They generally follow the normal model. Okay? A lot of different things. And if I represent the normal model, it looks like this. All normal models have this shape. And how would we describe this shape?
Bell curve.
Symmetric and
Unimodal.
unimodal. Alright, so whenever you are asked to describe the shape of a distribution, make sure you include both of those terms, okay? Symmetric and unimodal or bimodal or whatever, okay? If you just say symmetric, that's not enough. Alright, so let's try this out, okay? Let's say I put in this number, or in our model, I put 0 in the middle, okay? And if I tell you that this is 1 over here, then what number goes over here? Negative 1, good. Yeah, my positioning is a little off. Let me just, it doesn't matter, but 1 and over here would be negative 1, okay? And then so right here would be what?
Negative 2.
Negative 2, and right here? Negative 3, good. And we can go over here, and I would have 2 and 3. Is that okay?
Mm-hmm.
0 goes in the middle. So if I ask you, if I pick a number at random, what is the probability that this number is less than 0?
0.5.
Minus
Okay.
Over 6.
So if I pick a number at random from here, what's the probability that that number is less than 0?
0.5.
0.5. How do we do that?
Half.
Okay, well if I draw a line exactly at 0, and I'm asking what's the probability that the number is less than 0, how much is represented over here?
50%.
50%, okay? So 50%, or 0.5 of the area is to the left of 0. So the probability that a number is less than 0 is 0.5. Is that okay?
Mm-hmm.
It's a very basic concept, and so if you don't quite understand why it's 0.5, now's the time to ask your question. Okay, let me let's try this a little bit different, okay? So draw this again. Zero goes right there, and I'm going to put -1 right here. And if I shade everything to the left, and I ask, what's the probability that I get a number less than -1? What would you tell me?
Point 0.25.
Okay. Well, we know the answer. Whatever it is, it's less than 1/2, right? Okay. Just exactly how much it's a little bit unknown to us. Okay. And maybe my picture is not that great. Okay. I probably got the proportions wrong. Okay. But the true answer is like around 16%. Okay. About 0.1587. Okay. All right. About 16%. Okay. So probably my picture's not that great. Okay, well, any of these numbers that we throw out there, okay, we can get these probabilities by using the normal probability table. Okay. So, on one side you have negative. Okay, let's just look at this. Okay, let's look at page A2. A2 looks like this, and at the top you have -3.4, and at the bottom you have -0.0, and at the top you have 0.00, and then 0.01, 0.02, etc., etc., etc. Is that okay? On page A2 of your probability table? Okay, so the very first time we said, what's the probability that I get a number less than 0? Okay, 0 is the same as -0. Okay, there's no positive or negative. It's just 0. But if we looked at -0.00, that number we see is 0.5000 in that corner. Do we see that? Okay, and so that's saying if I draw a line at 0.00, technically negative. Okay, so that number right there says a line. So draw a line at -0.00. Okay, the area to the left equals 0.5000. Okay. Yeah, that's what we did up there. Okay. So intuitively from the picture we know that it should be 0.5, and the table just verifies that. Draw a line at 0.00. That's what this number represents. Okay. It's -0.0, and the column is 0.00. So it's, if you put those two together, you get -0.00. Okay. So if I draw a line at -1.00, at -1.00, how much do I have to the left? Okay, the area to the left equals 0.1587. Okay, that's that number there.
What are the other numbers?
Yeah, well, there's too many of them for me to write on the board. Okay, but they keep going all
No,
the way.
but like when do you use them?
Huh?
Like when do you
Yeah.
use
So we'll do an example right here. All right, is that okay? So we did -1.00. The area to the left of this line is 0.1587. Okay. All right. So let me. Is it okay if I erase this?
No, that wasn't.
Not yet. This one is okay. This is okay. Alright, I'm gonna draw another one. Alright, so if I draw a line at 0, and let's say, okay, let's say I go even further to the left. Not at -1, but let's say I go to -1.06. How much will I have there? Okay, before you look at your table, is it going to be more than 0.1587 or less than 0.1587? If I go to the left at -1.06.
Less.
Less than 0.1587, right? Because I'm further away, I'm going to have less in the tail. Do we see that? Okay, so if we go to the table, I'm going to go to the row -1.0 and the column 0.06. And how much do I have there? 0.1446. Okay, so the area here, 0.1446. So the table always gives us, when you look up a number, it says, if you draw a line at this thing, then the amount you have shaded to the left is equal to whatever's in there. Is that okay? So let's just try a couple examples here, alright? So using the positive and the negative side of the table, alright? If I draw a line at blank, how much area is shaded to the left? Okay, alright, so if I draw a line at -1.38, 2.00. .47 and -0.4.
Is this like how much like people fall into a category or something?
I'm just saying if using this thing, okay, with 0 in the middle, if I draw a line at those locations, how much area is shaded to the left? That's all I'm asking. Okay, I'm just asking you to use this table. It should be very straightforward. Because I just want to make sure we can use this table. Okay, everybody should be able to do this. I've passed out these tables, alright? If you want to play on your phone, you know, that's your deal, okay? I don't care, alright? Just don't be sad that you didn't learn anything in class today. You've got a table, just make sure you know how to use it. You're going to have to know how to use it next week on the midterm. And if you have no idea what's happening, ask questions. We have a question. No, we're only going to go to 2 decimal places. Okay. Let's try this out. Yeah, so there's a question, will we ever have to go to 0.474, alright? In reality, because it's continuous, technically yes, but in our class, because we are limited by this table, the numbers you look up, where in terms of where you draw lines, you're gonna have to round off to 2 decimal places. Okay. All right, so what do we get when we look up negative 1.38?
0.0838.
0.0838. Okay, what about 2.00? 0.9772. This is positive, right? Positive 2. What about positive 0.47? 0.6808. And what about negative 0.47? 0.3192. Yes.
I'm a little bit confused with the
Sure.
positive side.
The positive side.
Yeah, like say peace, for example.
Okay. So what happened there?
I just went minus.
Okay, so there's 2 sides to the table.
Oh.
Okay.
Yeah, that was,
Okay.
I thought it was
All right. I apologize. I thought
Sorry.
maybe I didn't make that clear. There's 2 sides to the table. One side you look up your negative numbers. The other side you look up your positive numbers. They both work the same way. We have a question.
I have a question.
Yes.
How do I know that, because it finishes with 8, right?
Uh-huh.
So I get 8 here.
Uh-huh.
So I find 1.
1.7.
So,
So you're gonna go to the row, negative 1.3,
And column 0.
and then the column,
Down 0.
0.08.
so that is this one.
Okay. Yes. Question. Yeah, I'm gonna get to that. Okay. Okay. So I've got the row negative 1.3 and the column 0.08. Is that okay? All right. So let's expand on this. All of these questions said how much area is shaded to the left. Okay. If I ask how much is shaded to the right, can we answer that?
Yes.
Okay. And how do we do that?
1 minus those.
Yeah, we do 1 minus that, right? So if I draw a line at negative 1.38 and it tells me that the area over here is 0.0838, how much is over here?
The rest.
Yeah, everything adds up to 1, okay? So the amount over here is going to be 1 minus 0.0838, okay? Just so everything adds up to 1. So how much is to the right of negative 1.38? Well, I look up 1 minus 0.0838, and I get 0.9162. Yeah, they're complements, exactly. Okay, so then go ahead, do this for B, C, and D. Alright, I'll let you guys write these things down. So all you have to do to get the area to the right is you take the area to the left and you do 1 minus the area to the left, okay? Is that alright? Alright, and what you might have noticed is that the area to the left of 0.47 is 0.6808. And the area to the right of negative 0.47 is also 0.6808. Okay? And the area to the left of negative 0.47 is 0.3192. And the area to the right of positive 0.47 is 0.3192. Okay? That's because this thing is symmetric. Okay? So basically what's happening in this picture, so looking at C and D, okay, so the area to the left, let's say negative 0.47, okay, according to this picture, this is 0.3192. But it's symmetric, so if I go over here to positive 0.47 and I ask for the area to the right, it's also going to be 0.3192. Does that make sense? Okay, so that's what we got going on here. It's actually D on this side and C on that side. I hope that makes sense. Okay, we'll take a short break.